class period, we learned how to write the equation of a line when given a graph, and we practiced that skill many times. What we're going to do today is we're going to write an equation of a line, but instead of being given a graph, we're just going to be given some information. The two pieces of information that we will be given is a point on the line and the slope of the line. So let's get started. First thing we need to do is talk about how we're going to write this line and the equation of a line. So what we're going to use is called point-slope formula. Now it looks a little bit different than y equals mx plus b. It comes in very handy when you're dealing with transformations later on in Algebra 2. So y is just the y, like in y equals mx plus b. And then it says minus y1. y1 is the y value in the ordered pair you're given. M is still our slope, it has not changed. X is the same x in y equals mx plus b. X sub 1 is the x value in the ordered pair that you're given. So now that we've gone through what point-slope formula is, we're actually going to utilize it in 3 examples. In the first example it says, write the equation of the line containing the point 3, negative 5 with a slope of 4. So our m is 4 and our point is 3, negative 5. Now in order to do this, I provided a chart for you in class that you'll fill out for your notes today. The first blank that it says point or points given. So there we're going to put 3, negative 5. Now, if we had to calculate the slope, which we've already done before, we would do that right here. But the problem is they don't tell us 2 points, so we don't have to do that. All they do is they tell us the slope, 3, negative 5. Now, here's where it kind of gets repetitive, but it asks for pick 1 point and a slope. So that's where we extract what we know from both of the other 2 boxes. So we know m is 4, and our ordered pair is 3, negative 5. That is all we need in order to figure out the rest of this problem. Now I have my formula wrote down here. It says we're going to substitute into point-slope form, and then we're going to solve for y. So, first step. We take the m, which is 4, and we put it in where I have the red 4. And then we put the ordered pair in, 3, negative 5. Now the formula is minus, so if you look here we have minus and negative. And right here we just have minus 3 because it was already a positive 3. Now once we've done that, we can do 2 things. We can turn minus and negative into an addition sign, so it's y plus 5. And we can go ahead and distribute the 4. 4 times x and 4 times 3. Noticing that the sign that was in between the x and the 3, the minus, has been dropped down. Now we go ahead and multiply 4 times x and 4 times 3, and that leaves us with y plus 5 equals 4x minus 12. Now we're almost there. We're almost in y equals mx plus b, but there's this plus 5 on the left. So I need to move the positive 5 to the other side of the equation. In order to do that, we have to use inverse operations. The inverse of adding 5 is to subtract 5. So I'm going to subtract 5 from both sides, making sure I've only subtracted it once from the left and once from the right. 5 minus 5 will be eliminated. And then I'll have 4x minus 12 minus 5 more, which is 17. So my final equation is y equals 4x minus 17 with a slope of 4 and a y-intercept of negative 17. Now that doesn't seem too bad, but what do I do if the slope is a fraction? Because a lot of times we have rise over run. Well, we'll talk about that in example 2. At any point in time in this video, if you need to pause it in order to fill in your notes or go back and re-listen to something, feel more than free to pause and do so. Okay, we're moving on to example 2. It says write the equation of the line containing the point negative 6, 4 with a slope of 2/3. 2/3 being the fraction. Now you can write it as 2 over 3, but I just wrote it as 2/3 because I'm using a computer program. My ordered pair is negative 6, 4. So I repeat the process just like before. This is example 2. I'm going to put my point in, and I know it seems repetitive, but it's good practice. I'm going to put my slope in, and then I know that I need both of those pieces in order to calculate the equation of my line. So it says once again substitute into point slope, which I have the formula right here, and solve for y. So here we go. So I'm going to take the negative 6 and put it where I see x sub 1. I'm going to put the 4 where I see y sub 1. And then 2/3 is going to go where m is, leaving me with this equation right here. Y minus 4 equals 2/3 times the quantity x minus a negative 6. Well, we know that minus and negative is a positive like we just did before. So that becomes y minus 4 equals 2/3 x plus 6. Now the process is just the same as it was before. I'm going to go ahead and distribute the number in front of the parentheses, which is a 2/3. And that will give me 2/3 times x and 2/3 times 6. The sign in between the two comes down, which is addition. And I'm going to go ahead and multiply. 2/3 times x is just 2/3 x. 2/3 times 6. Well, 2 times 6 is 12 divided by 3 is 4. So the equation now is y minus 4 equals 2/3 x plus 4. Well, I have to get rid of the minus 4. So once again, I add 4 to both sides, and that gives me my final equation of y equals 2/3 x plus 8. 2/3 being my slope, my rise over run, and my y-intercept of 8. That's where it crosses the y-axis. So we've done the situation where we just had normal integers for slope and points. We've done the case where we had a slope. That's a fraction. Now for the last example, what we're going to do is where I'm going to let x or y be 0. So the equation we're going to do is it says write the equation of the line containing the point 0, negative 5 with a slope of negative 1. So m is going to be negative 1 with a point of 0, negative 5. So I'm going to fill in my graph, or my chart, excuse me, with the information needed. Then I'm going to drop my point and my slope into the box. Once again, I'm going to let x be 0, x sub 1 be 0. I'm going to let y sub 1 be negative 5, and my slope is negative 1. So I've put negative 5 in here for x, y. I put a 0 in for x. Now, y minus a negative 5 becomes y plus 5, and I'm going to go ahead and distribute that negative 1 through. So we're going to take negative 1 times x, and we're going to take negative 1 times a negative 0. Well, that leaves me with y plus 5 because minus and negative is a positive. Here I've kind of broken it down to you, but you should realize that 1 times 0 is just 0. So now the equation we have is y plus 5 equals negative 1x plus 0. You don't have to put plus 0 there, but it's helpful because now I remember that I have to have my y-intercept. And I can't because I have y plus 5 and I don't want y plus 5, I just want y. So I subtract my 5 over because the inverse of adding is to subtract. And that leaves me with y equals negative 1x minus 5. Now if you've noticed here, I didn't put the negative 1 in. You can be negative 1x minus 5. But negative x means the same thing as negative 1x. So the proper way we're going to write this is y equals negative x minus 5. Now that being said, what if my slope was a positive 1x? Well, then you would just write x. I hope this has been helpful. We've done 3 examples of how to write the equation of a line in slope-intercept form.